Before we go into more details of how we can use the Snowflake platform, we first want to discuss at a high level what actually is a data warehouse. And if you're already familiar with this concept of data warehouses, of course, feel free to skip this, or if you have worked with data warehouses before. So in this case, you can just skip it. Otherwise, we will here just discuss this high level concepts of a data warehouse. And this might be helpful for you to understand how to work with Snowflake as well, to have this general concept of a data warehouse understood. So let's get started first of all with the purpose of a data warehouse. So what actually is the purpose of a data warehouse? The purpose of this is to consolidate and integrate different data sources and use them and optimize them for reporting and data analysis. So basically, a data warehouse is a database that combines different data from different data sources into one consumable database with the purpose of reporting and analysis. So a data warehouse is always a database for analytical purposes. So this is something we need to remember. Now let's talk about how this would work. So how do we set up a data warehouse? Let's assume that we have different data sources in our organization. So here we want to analyze data from maybe different departments, different systems, and they might be in different formats. Maybe we have some databases, we have maybe some unstructured data, CSV files, and so on. And analyzing now this data directly also on these operating systems is not very practical. For example, analyzing the data on this HR database might put unnecessary load and might interfere also with the operation that we are running here, maybe in the sales department or wherever this database is running. So therefore, we don't want to touch this database, or we at least want to spend as little time as possible on this database, and we don't want to use this database directly to analyze the data. So therefore, what we are doing is we run a so-called ETL process. So ETL stands for extract, transform, and load. So here we have these three things that we are doing. So step number one is we extract the data. So therefore, we spend not much time on this database, on this productive database, because we don't want to, spend lots of time there and risk that we are doing something we are not supposed to do, that we are just putting unnecessary load and might slow down something that is in production for our analytical purposes. And this is why we first extract the data. And for this, we use something like a raw layer in our data warehouse. This can be, for example, a separate schema or separate schemas, and maybe also even a completely different database. So here, this is not fixed, but a common approach is to use a different schema for this. So a schema is just organizing the database into different containers. And here in this raw data layer, we just put the data so we can quickly extract it as it is. And now if we want to do some kind of transformations, we can then also use the data integration layer for this. So in this layer, we can clean the data, we can transform it and integrate it. And here also we can establish relationships between different data sources. So here we can transform it and aggregate it as it is needed. And then we have one last layer. This is now the final layer that now makes the data available for various solutions. This can include here reporting purposes. Maybe we have some data visualization tool like Power BI where we are connecting directly to this layer. And here also maybe some data scientists can access the data or other applications, and they always usually access this access layer. And again, this is just one approach, and this is also not fixed. Sometimes the names are a little bit different, or the approach is a little bit unique in the situation where it's used, but this is just the general concept. All right. So first of all, I want to also in this case say that afterwards here we have this access layer, and here these can be different analytical purposes, but usually it is always an analytical purpose. So to summarize this, we have the raw data layer. This is the layer where we extract the data from the sources. And this is also sometimes called the staging area, because here we stage the data. This is not to be confused with so-called stages, which are objects in our Snowflake database. So these are database objects that we can create. And even though the name is similar, they are not the same thing. So a staging area is just a concept, and the stages are specific locations, and we talk about the stages very soon in Snowflake, what they are. But here, this is something that I just actually wanted to quickly mention. Then afterwards, we have also, as we have said here, this data integration layer where we are transforming the data. And then finally, of course, the access layer where we are connecting to the data. So this is a high-level overview over a data warehouse, and this should help us to understand how we work in Snowflake and just provide a little bit of context. All right, so hope it was helpful, and see you in the next lecture. So let's quickly understand the concept of cloud computing and answer the question, why is there actually a need for cloud computing? In case you are already familiar with these concepts, feel free to skip this lecture, of course. So historically, it was necessary to have a data center if this company or organization wants to or has to work with data. And of course, all of the companies nowadays have data and need to work with data. But the problem is that this can cause a lot of overhead, because this actually means that this data center is physically available in a building or a data center room. And this again can cause a lot of overhead. So we have to maintain and manage the infrastructure. We are responsible also for the security against physical and virtual breach. And the servers have to be cooled, which can again cause a lot of electricity. And then again, also we have the need for software and hardware upgrades. Maybe we need to create virtual machines and manage all of these servers and databases. And this can just cause a lot of overhead, a lot of costs, and we are also responsible for the security. And ideally, therefore, it would be if all of this could be outsourced and that the company can only focus on their application itself. That means only on creating their data warehouse as they need it. So this is what software as a service is. And Snowflake actually is exactly this concept, that it is a software as a service. So in this case, we are only responsible for the application itself. That means that creating the databases, the tables, and just implementing our databases and tables according to our needs. That means our data warehouse. And all of the other issues and responsibilities Snowflake is dealing with. In case of Snowflake, it's actually the case that these three responsibilities, so physical servers, virtual machines, and the physical storage, the cloud providers are taking care of. So mainly this would be AWS, but it's also possible that we use Azure or Google Cloud Platform for this. And Snowflake then is dealing with the operating system, the data management, meaning Snowflake is handling all of the metadata and the software that we can easily create and manage our databases and tables. So as all of these responsibilities are taken care about, we can focus on the application itself. That means creating and implementing our data warehouse according to our needs. So this is the benefit of software as a service, and also what the concept is that Snowflake is using here. So hope this could help you to understand why it can actually make sense to use cloud computing. So now that we've got this out of the way, let's focus again a little bit more on Snowflake specifically. In this lecture, we want to talk about the different editions in Snowflake. We need to understand what are the different features in those editions. And also, it's important to understand the pricing is, of course, different in each of those editions. But about the pricing, we'll talk about in the next lecture. So the first edition is the so-called Standard Edition. This is the edition that is made to get started. All of the foundational features are available there. Then if we are a large-scale enterprise, we have specific needs, and those can be fulfilled with the so-called Enterprise Edition. So all of the features from Standard are also, of course, included in Enterprise, plus those additional features. For example, we have so-called multi-cluster warehouses that really allow us to scale out efficiently and fulfill those needs of large-scale enterprises. And then, if we are a company that deals with extremely sensitive data, we have again additional features on top of the Enterprise Edition in the Business Critical Edition. So here we can comply with some specific regulations, for example, some financial institutions. And if this is not enough and we are dealing with highly sensitive data, for example, some governance or some financial institutions, then we have the so-called Virtual Private Edition. To set this up, we need to directly reach out to Snowflake, so this cannot be set up just by using the website. So in the Virtual Private Edition, we have the highest level of security because in here we have dedicated servers. So this is not shared with other companies, but we have our own dedicated environment, dedicated servers. And now, of course, let's have a closer look at the different features because this is very important also for the exam. In the Standard Edition, we have, as mentioned, all of the important foundational features. So we have also all data is encrypted. We have a broad support for all of the standard and special data types like geospatial data, unstructured data, semi-structured data. All of this is available in all of the editions. We also have the Snowflake specific feature of time travel. This allows us to travel back and query historical data that is not available anymore in the database, and this can be done up to 1 day in the past. And we'll talk about this time travel feature later on as well. On top of this, we have also the disaster recovery that is called failsafe. This is a disaster recovery, so we need to reach out to the Snowflake support, and we can recover data in some disasters for up to 7 days beyond time travel. And we have also the features of network policy, secure data share, federated authentication and single sign-on, as well as Premier support in all of the editions. So this is available in all editions. But now, as mentioned in the Enterprise Edition, we have also those so-called multi-cluster warehouses that we'll also talk about in the next lectures. And also we have time travel now up to 90 days, and we have again some additional features like materialized views, search optimization. We also talk about this in the next few lectures. And also we have so-called column level security, so we can show and hide some specific columns based on the roles of the users. So this can be also set up starting from the Enterprise Edition. And also, we have the weekly releases where we can get some early access. So, as mentioned for the business critical, we have now these additional security features to make sure that we can comply with some specific regulations. So, some features are, for example, customer managed encryption, or also the support for some specific data regulations. So if you want to know all of the exact details, you can go to the Snowflake documentation, and there you find the exact matrix of all of those exact features. I've just summarized the most important points, but for example, if you scroll down to security, governance, and data protection, you will see that some of those specific regulations are only available in the Business Critical Edition. So this is only available in here. And here, for example, we have support for this PHI data regulations. This is all only possible starting from the Enterprise Edition. So if we have those needs, we can fulfill them with the Business Critical Edition. On top of this, we have some additional disaster recovery. So we have seamless database recovery. So this is just some additional security feature, database failover and failback, also starting from Business Critical. And then, as mentioned, if this is still not enough and we need to have dedicated virtual servers and a completely separate environment, including dedicated metadata store, we need to reach out to Snowflake directly to get access to this virtual private edition. So this is a completely isolated Snowflake account that is not sharing any of the hardware that is used with any other customers. So of course, this is then also possible. So these are the different editions. I know in the beginning this seems like a lot, but it's important for the exam, and I'm sure that after a while you quickly get the hang of it. And now, of course, we also want to talk about the pricing in Snowflake. In this lecture, we want to talk in a lot of detail about the pricing to fully understand all of the costs in Snowflake. We have two main types of cost. The first block is compute cost, and then we have also storage cost. The benefit in Snowflake is that those two main blocks are decoupled. This is what we've seen in the different layers in Snowflake, and the benefit is that we can now scale them independently. When we need more storage, we can just increase storage and we don't need to add and pay for additional compute. So like this, we only pay for what we need, and we are very scalable and get those compute and storage with a very affordable cloud prices. So Snowflake, as we have already learned, leverages the external cloud providers like AWS, Azure, and GCP, and we can benefit from those affordable cloud prices, and we can independently scale them up and down. So, of course, therefore, the pricing depends on which region and which cloud provider our account is based on. Aside to those two main blocks, we also have some data transfer costs in some situations, and therefore in the end we also quickly mention when those data transfer costs occur. But we want to start with the main block, which is the compute cost. The compute is separated into three different parts. So we have again here three different aspects. And the main one are the active warehouses. So here we are only paying for warehouses that are active. We can also suspend them, and then we are not paying for them. So the warehouse is the standard cost that occurs with compute, and this is used for the standard query processing. So whenever we want to execute a query, we need some compute power, and this is coming from the warehouses. Additionally, we've also learned about the cloud services layer that is needed for some behind the scenes cloud service tasks. And of course, this is managed fully by Snowflake, and we also need to pay for this. But usually those costs are quite small, and we are not even charged for this unless those costs exceed 10% of our warehouse consumptions. Otherwise, we are not even charged for this. So usually we are actually not even charged for this unless we have really a very low activity with our warehouses. And then we have one last block, which is the serverless. These are also some warehouses that are needed for some specific features like automatic reclustering, search optimization, and Snowpipe. And here it makes sense for those features that we also need some compute, but that it's managed by Snowflake. For example, with Snowpipe, we have some data that can be automatically loaded when a new file appears somewhere in an external cloud provider. And therefore it can be automatically resized depending on the needs. And therefore it makes sense that this is a serverless feature where we have no control of the warehouses, of resizing them, and so on. So this is also then managed by Snowflake. But now let's dive deeper into the main cost, which are our active warehouses. In here, we are charged for the active warehouses per time. We get a price tag per hour, but this is actually billed per second. So if we only use 30 minutes, we are also only paying for 30 minutes with always a minimum of 1 minute when we start a warehouse. So the cost again depend on the time and also on the size of the warehouse. And like this, we have 3 different factors that affect the cost. This is how much time, how many warehouses we have active, and then also what are the sizes of those warehouses. So in just a second, we talk about how this works exactly. But before this, we need to understand that we are not charged directly in euros or dollars, but we are actually charged in credits. So we consume those credits, and then those credits have a certain price tag. And therefore, we need to understand 2 things. First, how this consumption works, and then also how much do those credits cost. So let's start by understanding the consumption of the credits. This depends on the amount of time a warehouse is running and the size of the warehouse. So for example, we have the size extra small, this is the smallest, that consists of 1 compute node. But if we have some more complex tasks, some more complex queries, we need more compute power and we can increase the size of a warehouse. So then we have 2 compute nodes, and like this we also now have 2 credits consumed per hour. So the number of compute nodes that are needed, this is the amount of credits we are charged per hour. And you can see once we increase the size by 1 step, we double the amount of servers that are needed and therefore also the amount of credits that are used. So like this, we can choose the size of the warehouse depending on how much compute power we need. And now, how much do those credits cost? This is now where the editions come into play. We have for the standard edition the lowest price, and then for the higher editions we have a higher price per credit. But now this is again depending on which region and which cloud provider our account is based on. So they have different prices in different regions and different platforms. So therefore we have also different prices. And in here we can see, for example, the price of US East in AWS. And if we have another region, for example in Frankfurt, the prices can differ. And also, if we want to know more details on this, we can go to just snowflake.com/pricing. And in here we can choose, for example, let's say AWS and US East. And we can see here, these are the prices for those different editions. But now we see that there's also storage cost. And therefore, we want to dive deeper into this in the next lecture. Now that we've already talked about the compute cost, we also want to discuss the data transfer and data storage cost. There is a monthly fee depending on how much data we have stored on average in a given month. So this is calculated on a daily average basis. And again, since our account is leveraging the external cloud providers for the data storage, this depends on which is the cloud provider and the region that our account is based on. So for example, if this is based on US East and AWS, we have a cost of $40 per terabyte per month. So this is based on the cloud provider's cost, and also the cost is calculated after the data compression. We know that Snowflake compresses the data into blobs, and this is therefore important that this amount of data is calculated after this data compression. Now, in regards to the storage, usually the default is that we pay on demand what we are using. So we pay for what we have used in a given month once the month has been ended. And then again, depending on the region, we have a specific price. So this can differ again on the different regions. So for example, if we choose another region, for example Frankfurt, we see the prices can differ. But now there's also another way to save on some cost, and this is to reserve some capacity storage. We can also see that in here, where we have to pay upfront for a defined capacity, and then this will be a lower price. But of course, we should have a good understanding of how much we need actually. And to demonstrate this, let's have a look at the following scenario. We assume that we need 1 terabyte of storage. And in this case, we would have to pay upfront $23 for the capacity storage. But of course, now let's assume the following scenario. We have only, in fact, needed 100 gigabytes, so we needed much less. We still have to pay the full $23 that we have paid upfront, even though we just used a lot less. And therefore, in this situation, if we don't have a good understanding and we actually needed much less storage, we would have been a lot cheaper with the on-demand storage. But now, in another scenario, when we actually are close to what we have estimated, we can see in on-demand, we now would have to pay more than in the capacity storage. So like this, we can easily see that it's smart to start on-demand. And then once we have a good understanding about our usage, so after a while, we should get a actually pretty good understanding for how much we need, we can then still shift towards the capacity storage just to save on some additional cost. But now that we have discussed the compute and the storage, there's still something left for the data transfer. So this is something that I also quickly want to mention. In general, data ingress is free, so we are not charged for getting data into Snowflake. This is also because the external cloud providers, they also don't charge for data ingress. So this is free, but once we want to get data out of Snowflake, the cloud providers charge, and therefore we also have costs for this. So this is based again on the different cloud providers. We can have a look again into the website under the pricing guide. And now if we scroll down, we can choose the on-demand, so based on what account and so on, but we can also see the pre-purchase capacity, and there we also see the data transfer cost. You can, for example, see for AWS, if this is just within the same region and the same cloud, so still AWS, we would not pay anything. So if we want to transfer data to another Snowflake account, but this is the same region and the same underlying cloud provider, we would not be charged for this. But once we want to send it to a different region in the same cloud, it is getting more expensive. And if we want to even send this to a completely different cloud provider, this will be even more expensive. So you can see all of the prices for Azure, AWS, and GCP. This is important to understand. Data ingress is free, but once we want to get data out of Snowflake, this will be charged. So when does this occur? This occurs when we want to transfer data or replicate data to another account that is not in the same region or that is not the same cloud provider. So if it's in the same region and the same cloud provider, then this would be also still free. So this is what we need to know about compute cost, storage cost, and data transfer cost. Now let's have a practical look at how we can monitor the cost in our Snowflake account. First of all, I want to mention that, of course, as part of the free trial, for the first 30 days, we have a credit that we can use up in these days. In my case, $400. And now we want to see how we can monitor the cost. To do this, we need to have the role account admin selected, or another role that we have created apart from those default roles that have sufficient privileges. In our case, it should be the account admin. So we need to select it, and then afterwards we can navigate to the admin section, and in here under cost management, we can have a look at the cost. So in here you can see immediately that at the top corner there is this warehouse, and this will be spinned up automatically because we also also need to have a warehouse that is used to generate the data and run the underlying queries to get this data, so to get the understanding of the cost management. So there are also some queries that need to be run. So if you have some message that you need to select a warehouse, you can also select it. Just make sure that you are selecting a small warehouse, because we of course want to save cost and we don't need to have a lot of compute power to do this. So what we see in here is, first of all, in the account overview, the amount that we have spent in some very easy metrics. So you can see for the selected period, I have just selected the last 7 days. I can see the amount I have spent and also the amount of credits that I have used. So since we pay, in our case, $3 per credit, we can see that this is actually the amount. And then this is also broken down on a daily basis for the credits and the amount. Additionally, we also have the overview over the top warehouses. So this is also a good overview. And then there's also this warehouse that is not created by us, but this is the cloud services only, which basically is a dedicated warehouse for the cloud services layer. So this is just used for administrative tasks like metadata management or authentication. And this is, something that is outside of the warehouses that we have created. And then also we see here the data by the storage. So of course we also have storage cost. And here we just see the most expensive queries. And then if we want to dive a little bit deeper from here, we can go into the consumption. And again, here we can filter it, of course, by the date. And also we can do it by the usage type. So we can break it down by the main categories of cost: compute, storage, and data transfer. Also, if we have multiple accounts, which can be possible, and we are the org admin, we could also see the other accounts. In our case, this is probably not the case. And now, if we select our specific account, we can see more detailed information. So first of all, what I want to select is, under all usage types, I want to select first compute. This is again the most important category, because usually this is where most of the costs are occurred. And if we select compute, you can see that we have even now more filters. So you can see we have tags, which we talk about in a second. And then we have also all services, and then also all resources. So you can see here under all resources, we just see the resources, basically in this case, all of the warehouses that are consuming credits. And in the same way, we can also filter this view by those different types, so by those different categories. And here we have services, resource, and type. And I know in the beginning this might seem a bit confusing, so we don't want to spend too much time on it, but I just very briefly want to mention that by service is just separating the resource consumption into warehouse consumption and consumption by each serverless feature. For example, here, warehouse metering that we can see if we hover over here is just representing the credits that are consumed by the warehouses that we have created. So this is all that we have. And then we would have also later on with the feature Snowpipe, the pipe. So here we would see pipe, and this is just a serverless feature that is used for Snowpipe to continuously load data. But again, we don't need to dive into too much detail in here. And then we also have type, which sounds a little bit similar, but this is just separating the resource consumption in a different way. So it is basically separating it into compute, which we can see if we hover over here. So it is compute, and this is basically both the virtual warehouses that we have created, all of them that we can see in here, and also the serverless resources. So this is just combined. And then also on the other side, we have cloud services. So you can see in here cloud. This is the cloud services layer where we have also the consumption that you can see in here. So again, this is for the administrative tasks where we have the cloud services layer. And then we can also, of course, filter that up here. So we can say we want to filter by specific resources, and we can also, of course, filter it by day, or if we have more data, also by other periods. And also now we want to talk about the tags, because this is a relatively new feature, and we can also see that in here in our resources. And tags Again, we don't want to dive into all of the details, but this is just in general. In other cloud providers, we also have those tags, and basically this helps us to categorize our cost, and we can set up our own categories. So a tag is just a key value pair. This means we can set up a key, for example, department, and then a value, for example, it can be sales or marketing or maybe analytics team. And like this, we can create our own categories and we can view the costs based on our own categories. For example, we could say we have the environment, test environment, and also maybe productive environment or development environment. And like this, we can apply multiple tags to our resources if we have sufficient privileges to do this. And then we can break down the costs by those categories. So this helps just with the cost management. Additionally, we not only have, of course, the cost, but also we have the storage. So we can also see that in here. And we can see the cost is again broken down by different categories, and we don't need to dive into that also now. For now, just we see those different categories and we talk about those features as well. Later on, for example, failsafe is just some data protection feature in Snowflake that is protecting data basically from something like a system failure or something like this to protect our data from being lost. So something that we talk about later on as well. But here we just see how the data is broken down, basically also by the different objects in here. And again, we can also filter it by day and so on, by the object and so on. This can also be done in here. And then lastly, we also have the data transfer. So in here, we know that we are also charged for the data that is transferred into our account. We are not charged. So we are only charged for the data that is transferred out of the account or to another region. And this could be then seen also in here. So of course, we also have this data transfer cost, which can be also viewed in here. And we could also break it down by the region and so on. So this could also be done in here. All of the other filtering methods like the date range and so on. So here we can get an overview. And then we also have these resource monitors, which also help us to monitor the resources of specific objects, of specific warehouses. How this exactly works, we now want to have a closer look at in the next lecture. In Snowflake, we can create so-called resource monitors. Those are objects that we can use to control and monitor the credit usage of both warehouses and also our entire account. This is a feature that's available for the standard edition and higher editions, so basically for all of the editions and all of the accounts. And in these resource monitors, we can set a so-called credit quota. This is like a limit that we can set in a defined cycle. So for example, every month we have a limit that is just then reset every month. We can of course also customize this schedule, but the default is just that this resets every month. And those resource monitors we can set for the account level and also for individual warehouses. And on top of this, we can also set them up for a group of warehouses. So we can select multiple warehouses and put one resource monitor, so one limit on these multiple warehouses. And then based on the quota that we have set, we can define specific actions. So we have 3 types of actions and we can say at what percentage of the quota this action should happen. And these 3 actions are first just notify us when, for example, 50% of the credit is used. Then we have the next action, which is suspend now the warehouse and always notify me. So all of the actions always include notify. But this will then also suspend the warehouses. But it's important that suspend here means that it will still continue the ongoing workload. So the queries that are still being processed currently, they will be completed, and only after this current workload has been finished, this will then suspend. So this means that we can exceed this limit. And then if we want to be a bit more rigorous, we can also use the action suspend immediately and notify. And this will then suspend the warehouse or the warehouses immediately, and this will also abort the current queries. So if we have some queries that are currently running, this will also immediately stop those queries. So they will be aborted and they won't be completed if this limit is reached. And also be aware, you can also use here percentages that are above 100%. This is also possible. So those resource monitors can be created to control and monitor the usage of our credits. And they can only be created by users with the account admin role. And later on, we'll talk in more detail also about the different roles. And even though this can be only created by the account admin, we can delegate some tasks. So we can just grant privileges of monitor and modify on specific resource monitors. And then those people with those privileges, they can also view and monitor the existing resource monitors. And lastly, I also quickly want to mention that these resource monitors can be used to track the usage of the cloud services that are needed to execute certain queries related to a virtual warehouse. So we can of course set a limit in which then a warehouse should be suspended, but we cannot prevent entirely the usage of cloud service. So we cannot necessarily prevent cloud service usage that is related to a warehouse. This is just something that's a little bit specific, but I also wanted to mention this. So this is what we need to know about resource monitors, and now we want to just put this into practice and create such resource monitors hands-on in Snowflake. In this lecture, we now want to have a look at how we can set up resource monitors in our account. So basically a resource monitor helps us to create a budget, and we can take two types of resource monitors that we can create. The first one is on an account level. So this will be for all of the account together. And then for individual warehouses, we can also set those resource monitors. And how this works now in detail, we want to have a look at now. So first of all, we have to select the account admin role for this, because this is the only default role that can be used to create those resource monitors. So make sure you have this role selected. And then you need to navigate into cost management, and then here under resource monitors you can see all of the existing resource monitors. So also other roles can see them, but only the account admin can actually create them. So therefore we in our case want to now do this. So we click here on resource monitor to create a new one. And first of all, we have to give it a name. So here, just give it a descriptive name. So in our case, we want to create an overall budget, a monthly budget for our account. So let's say we call it account budget. We can also say account or monthly account budget. So let me call it monthly account budget. And be aware, we cannot use white spaces here. So this is an invalid character. So we have to use those underscores if we want to separate this. So I say monthly account budget, and then we have to specify the quota. So here, how many credits is the limit basically? What is the quota here in the given cycle? So in the given period. And here we can also define the period. So here in our case, it's monthly, which we could customize, but here we just specify in our case now, for example, 10 credits as just an example. And then here we have, as mentioned, those two types. So we have either account or warehouse. In our account, it should be, or in our case, it should be about the entire account. And then here again, we could set the schedule, so we could customize it and change this, but we just leave it actually at this default, which says that it starts immediately with the monitoring, it resets every month, so once a month, and also it never ends. So this is just our schedule, a monthly schedule basically. And then here we have the important actions. So here we have three different types of actions that we can use. The first action is basically just notifying us. So we get an email when a specific percentage of credits of our quota is used. For example, if I enter the value 50, this means that now when we have reached 50% of our quota, i.e. 5 credits, we will be notified. But nothing happens, everything continues, nothing will be shut down. But then we have also here at, for example, 80%, we can set that it should now suspend and notify us. So then we will be notified, and also the warehouses will be shut down. So this, though, allows the running queries to complete before they will be suspended. So maybe we have some, we don't want to abort the existing queries because maybe they are important, and therefore we first finish all of those queries. They will not be aborted, and then after that it will shut down the warehouses. So this means that it can consume more than those 80%, but then after this is reached, everything will be shut down. So after the queries are completed. And then if we want to be more strict, because maybe some of those queries run for a very, very long time, and we want to be really sure that it's immediately shut down at a specific percentage, for example, at, let's say, 99%, then immediately everything should be aborted and no more credit should be used. Then we can also set here this suspend immediately. And this will abort all running queries and immediately suspend the warehouse, so no more credits are used. You could even leave a little bit of a buffer and use more than 100%, for example 105%, if you want to make sure that really everything is still completed and nothing will be aborted, so that you have a little bit of a buffer. But then at this point it should be shut down. So like this, you could create a resource monitor, and you could also add more of this. So you can also say that you want to be notified maybe at also already 25%, so you can add also an additional action. In our case, we don't want to have this, so we can also remove it, and we can create the resource monitor like this. And then we will see in just a second that this resource monitor will be created and it will be in place. And here we see it has been created and now it is working. So now it is in place and it is taking those actions based on the percentages of the quota that we have set up. All right, so this is how we can set up the resource monitors. Hope it was helpful, and see you in the next lecture. Now let's briefly talk about the roles, and the purpose of this lecture is basically just to get an overview over the roles, because we will use them and you will see them, so you have a brief understanding of how this works. And later on we will have also a dedicated section about access management, privileges, roles, and so on. So don't worry, we will dive deeper into this later on. But for now, let's first of all have an overview over this. So you can see that we have those system roles, and also we have the role org admin that is a bit outside of this hierarchy, but this is basically the hierarchy of roles in Snowflake. So here you can see that the public role is assigned always actually to every user that is created. And then when we assign privileges, this is what we are doing. How this works, we have roles, and then we assign privileges to the roles, and this will be inherited up the hierarchy. So here you can see how this works. We have a role, this can be a system role or also a custom role that we have created. And note, when we create a custom role, it should be, as a best practice, assigned to the sysadmin, because the sysadmin is managing the warehouses and the databases mostly. This is the purpose. And then in this case, it makes sense to assign the custom role as a best practice to the sysadmin. And why this is exactly the case, we also talk about in the dedicated section for the access management. So in general, as we have said, we assign privileges to roles using the grant command, and then afterwards we can also grant and revoke those privileges. For example, a select on a table, so that a table can be seen, and then every user that is having this role assigned is now able to then do this, what the privilege says. So again, we can then also grant the roles also using the grant command to the user. So we grant permissions to the role, privileges, and then the role will be granted to users. This is basically how it works, and one user can have multiple roles assigned to them. So we talk about this later on in more detail, and every user always needs to have also a current role in the session. So if we jump into our account, we can see if we go into a specific worksheet, then also every query will be also executed using a specific role. And then always when we, for for example, create an object, the owner of this object will be the role that has created this object. So we have also this concept of ownership. This is also important because every object is usually owned by a role. So when we create it, per default, this is the owner. So this is basically how it works. And then, as we have said, we have those system-defined roles. They can't be dropped, and we can add privileges to it, but we cannot revoke privileges. But again, we talk in more detail about this later on. For now, we just briefly want to mention we have the custom roles should be assigned to the sysadmin, and outside of this hierarchy we also have the org admin. So this is something that you might notice, and this is basically managing actions on an organizational level. So if you have multiple accounts, this is the role that can create additional accounts. We talk also about read accounts and so on. So this is something that can be done here also for the org admin to do those organizational level, and this is therefore a little bit outside of the hierarchy. Then we have the account admin. So this is the actual top level role of our hierarchy, and everything will be always inherited, all of the privileges up to the account admin. So this is a very strict role because it's a very powerful, the most powerful role. So we should be very careful because this has a lot of privileges, including also managing the share and reader accounts. So we can create those share and reader accounts. And we talk about this later on. For now, we just briefly want to mention the overview. So security admin is managing the grants globally. This means that we can manage the grants of the privileges. So we can create and monitor the users and the roles. So here, of course, the user admin is able to create the users, and the security admin is able to manage the security part of that. So here also all of the user admin privileges will be therefore, of course, inherited. And then we have also the sysadmin. So basically they are doing all of the warehouse management and the database management and the object management. And this is exactly the reason why we have to assign the custom roles to this role, because then otherwise it could create some conflicts when the sysadmin is creating a database, and then with the access we would get some problems. But we talk about this in more detail as mentioned later on. We have also the user admin, basically creating the users and the create role. So create users and create roles. So this is the management of the users. And finally, as we have said, we have also the public role. So this is the role when we need no access. This is just the default role. So every user that is created will have this role assigned. And this is, therefore somehow some kind of a pseudo role. So it will always be assigned. And then again, we can create those hierarchies, which don't worry about it now too much. This is something more for later. So of course, this is just the brief overview so that you have heard a little bit about those roles. What are the broad differences, and into the details we will dive in later on. So hope it was helpful, and see you in the next lecture. Now let's talk about one of the most important concepts in Snowflake, and also when we talk in general about data